the primary battery. In Chapter 2, we'll jump from pickles to commercially produced batteries. With your pickle battery background, you're in a great position to learn how a primary, non-rechargeable battery works. We'll learn from the popular alkaline battery, outside and inside, understanding that all primary batteries work on similar principles. Batteries of this type or form are protected by a metal jacket with a plastic wrap over the top. One end, one battery terminal, has a small metal projection. It is the positive terminal. You've probably noticed that end of the battery always has a positive sign imprinted on it. You know by now the positive terminal is called the cathode. The flat end of the battery is designated the negative terminal. You know the negative terminal is called the anode. Before looking inside our battery, some clarification is required. This illustration accurately reflects the interior geography of an alkaline battery. Our illustrations and descriptions have been simplified to provide a conceptual understanding of how an alkaline battery works. Our model battery blueprint looks like this, so you may more easily visualize and understand battery concepts. Now, let's get started. Connected in a circuit, electrons from a battery will flow from the anode, negative terminal, to the cathode, positive terminal, as you see here. Remember, the flow of electrons is electricity, and electricity from the battery will power an appropriate load. The anode material in an alkaline battery is made of zinc metal particles suspended in a gel to keep it evenly distributed. Connected in the circuit you see, electrons will be lost by the zinc. The zinc is oxidized. Oxidation, the loss of electrons, happens at the anode, the negative battery terminal. The cathode material in a typical alkaline battery is a form of manganese dioxide, MnO2. It's mixed with a type of carbon or graphite to help transfer charge. Connected in the circuit you see, electrons will be gained by the manganese dioxide. Manganese dioxide is reduced. Reduction, the gaining of electrons, happens at the cathode, the positive battery terminal. In every battery, there must be an electrolyte to allow for the free movement of ions, permitting electricity to be produced. In an alkaline battery, the electrolyte is usually a solution of potassium hydroxide, KOH, dissolved in a water-based paste. Potassium is an alkali metal, hence the name alkaline battery. Chemical ions can move through the electrolyte. Equally important, electrons cannot move through the electrolyte. To move from the anode to the cathode, electrons must flow through wires using an electrical circuit for their path. Our last feature is a safety feature. Most commercially produced batteries have a physical barrier to prevent an internal short circuit. The barrier is called a separator. It prevents physical contact and the direct transfer of electrons from the anode to the cathode materials, which are actually much closer together than is indicated here. However, the separator must also allow ions to move through the electrolyte for the battery to produce electricity. For this reason, the separator has microscopic pores or holes in it that allow for the passage of ions and molecules. Close up, you can see the separator is made up of microscopic fibers, often made of plastic. It does not allow anode and cathode materials to contact each other, but dissolved ions and electrolyte chemicals may pass through. Let's recap. What are the desirable properties for all battery materials? They must provide for reliable, powerful discharge. They need to be chemically stable when not in use. Typically, they are made of solid materials rather than a liquid or a gas. Batteries are generally small and lightweight, especially for mobile applications, relatively safe to handle in production, and price competitive to produce. The anode material, it must be electrically conductive and have a chemical tendency to lose electrons. Most metals fit this description. That's why materials such as zinc, lead, and lithium are common battery anodes. And the cathode material, it must be electrically conductive and have a chemical tendency to gain electrons. Metal oxides, such as manganese dioxide or nickel oxide, are often used. Oxygen seeks to gain electrons. However, metal oxides are poor conductors, so these materials are mixed with carbon, graphite, or other additives to improve conductivity. And the electrolyte? It needs to allow for the movement of chemical ions through it. It must prevent the movement of electrons through it. And it must be unreactive with the anode and cathode. Finally, the separator. It must be chemically unreactive. It's porous to allow chemical ions to pass through it, and ideally is thin but strong. A final question to tackle before moving on. What is the voltage of an alkaline battery? The reduction potential difference between the manganese dioxide cathode and zinc anode is 1.66 volts. However, this voltage drops as the cell discharges due to various adverse reactions occurring at the cathode. For this reason, alkaline batteries are sold with a nominal or nameplate voltage of 1.5 volts. The actual operating voltage of the battery can range from roughly 1.65 volts when new to about 1.25 volts when its capacity is around 90% discharged and effectively dead. Of course, as you've learned, the output voltage of a battery is also influenced by the nature of the materials in the battery and their purity, the type of electrolyte and its concentration, and always the environmental conditions around the battery.